Assalamualaikum warahmatullahi wabarakatuh. I want to explain about our project, which is application of numerical mathematics in civil engineering area. My name is Muhammad Zikri bin Osli, and my other group mates is Izani Faizi bin Ibrahim, Nur Dania Akila binti Muhammad Syair, Nur Maizatul Husna binti Zulkifli, and Nurul Nadia binti Mat Yusuf. Introduction of our project is Encik Ateta is working as engineer for a submarine manufacturing company in Russia that makes submarine for the Russian Navy. Encik Ateta is asked to find the depth for one of those submarines that were recently made by his company, to which the submarine is submerged when floating in the water. The depth of the submarine will submerge when floating in the water will be calculated using Newton-Raphson method. The objective of our project is first to know the depth to which the submarine is submerged when floating in water using Newton-Raphson's method. Second, to find the relative approximate error and number of significant digits at least correct after each iteration.
Problem statement. Encik Arteta is working as an engineer for a submarine manufacturing company in Russia that makes submarine for the Russian Navy. Encik Arteta is asked to find the depth of one of those submarines that were recently made by his company, to which that submarine is submerged when floating in the water. The submarine has a specific gravity of 1.25, a diameter of 8 meters and length of 11 meters. So this is the equation given when the submarine is submerged under the water. By using the Newton-Raphson method of finding roots of the equation, find 1. The depth x to which the submarine is submerged underwater. Conduct iteration to estimate the root of the question given. Second, the absolute relative approximate error at the end of each iteration.
My name is Nurul Nadia binti Mat Yusuf, and my matrix number is AF2000-7. Okay, so this is the filler table for the problem statements. Okay, so for the questions number 1, so what is the fact? The fact is estimating depth of submarine submerged underwater from this equation. Okay, so after that, for the ideas, the linear equation given can be solved by Newton-Raphson method. Okay, so this is the equation. So the learning process is how many iterations will be used until got the exact value of root. For the action, find the information how to use the Newton-Raphson method through numerical method books or any reference book. Okay, so for the questions number 2, the fact is absolute relative approximate error at the end of iteration. Okay, so what the ideas? So find the absolute relative approximate error using this formula. Okay, so this is the formula how to find the absolute relative approximate error. Okay, so what is the learning process? What is the number of significant digits to make sure the value is correct? Okay, so the action is look at the example from reference book to know what is the general numbers of significant digits, such as 0.0005 less than of that number.
Assalamualaikum. My name is Izani Faizi bin Ibrahim. My matrix number is AF2001-804. So today I will talk about the solution for this problem. So firstly, the equation for this problem is 35x cubed minus 25x squared plus 17x minus 10. So we differentiate this equation and we get the new equation, which is f prime x equal to 105x squared minus 50x plus 17. And we get this graph from this equation. So let's assume the initial guess of the root fx equal to 2. Then we substitute this initial guess, initial root into the equation fx and f prime x. So for the x, for this table, for x is initial guess, which is root. So for fx, we can substitute these two into the equation and we get 204. Then for this f prime x, we substitute 2 and we get the value is 337. So for this new iteration 1, we can get this value 1.39469 from the equation, which is 2 minus which 204 over 337. So we can get this value. So we can calculate for this equation and so on. And lastly, we can stop at iteration 6 because the value for this fx less than 0.00005. So equation, we calculate the absolute relative approximate error for this every iteration. So the first iteration we get 43.40%, and for the iteration 2 we get 39.68%, iteration 3 we get 30.84%, and iteration 4 we get 14.94%, and iteration 5 we can get 2.61%, and lastly we get the for iteration is 0.07%. Then this is for from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Maizatun Sina binti Zulkifli. My metric number is AF200101. So for the conclusion, based on the problem that faced by Ensure Data, it can be solved by using a Newton-Raphson method, because this method it's more become easier and simple for finding successfully better explanation to the root or zero root of real value function. So now he can know the depth to which the submarine is submerged when floating in the water, and he also can know the relative explanation error, and so that the problem that faced by Ensure Data can be solved with success.